Hi there, we're going to talk about salt ocean. So again, we're talking about pH tox. So in our blood, we try to keep our body keeps our blood at a really close level of pH at 7.4 so that all the chemical processes are normal and healthy in our blood. So in our blood, we have something called a buffer. Blood at a stable pH, no mass is added to our blood or more bases added to our blood. Our blood system buffer to really close to 0.4 so that everything will be healthy in our body. So we're going to talk about buffers and how they work in our body. So when is the solution of a salt acidic or basic? So when any type of salt is added to water, it can change the pH of the solution by having a chemical reaction. So salts that make acidic solution contain positive ions that release protons to water, and salts that produce basic solutions when you add them to water contain negative ions that attract protons. So I'm going to show you how this works. This is called salt hydrolysis. The cations or anions of a dissociated salt remove hydrogen ions from or donate hydrogen ions to water and change the pH of water. That's called salt hydrolysis. So for example, if I take ethanoic acid and sodium hydroxide, this is a neutralization reaction. I form sodium ethanoate and water. If I throw that sodium ethanoate salt into water, it breaks into two pieces, ethanoate ion and sodium ion. That ethanoate ion will react with water and form the ethanoic acid again and make some hydroxide. So it makes the solution basic. So this salt, if I add this salt to water, it makes the water basic. So we have to be able to predict what's going to happen to water when you throw salt into it. So I showed you this earlier. If you have a strong acid and base, you get this really sharp equivalence point. When we do this with a weak acid or base, we get this not such a sharp break right there compared to this one here. We have a nice long sharp break right there. So this is showing you, the red is showing strong acid and base. You'll see this type of titration curve when you use a pH meter for a weak acid and base. So here's the rules to know. Strong acid and strong base together make a neutral solution. They cancel each other out. Strong acid and weak base is going to form into an acidic solution. Weak acid, strong base is going to form into a basic solution when we do the salt solutions. So here's an example. We have hydrochloric acid concentrated. We have concentrated sodium hydroxide. When the vapors come off of these two glass ammonium chloride. So I've got ammonium chloride can break into ammonium and chloride in water. Aqueous means water. This ammonium, so this is a salt. I'm throwing it in water, and I'm making these two ions pop up. It dissociates into these two things. This, in water, will make H3O+, which means I've made this water acidic. So that's how we predict. Here's ammonium chloride. It made the water acidic. When I threw that salt into water, it made it acidic. When I throw salt into water, since this is from hydrochloric acid and sodium hydroxide, it makes that strong acid strong base. It makes a pH of 7 when you put the salt in water. If I throw sodium ethanoate into water, it makes an acidic solution. Okay? So every salt you throw in water can affect the pH, and you can have that hydrolysis that salt hydrolysis we just showed. Okay? So let's talk about a buffer. We were talking about this in our blood. We breathe in carbon dioxide, and we form a carbonate buffer system in our bloodstream. So a buffer is a solution of a weak acid and one of its salts, or a solution of a weak base and one of its salts. So the pH of a buffer remains really constant. Even if you add acid or base to it, it just gobbles that up and so that it doesn't affect the pH of the overall solution. The buffer capacity is how much acid or base can that buffer gobble up without changing the pH level. So let's look at a buffer of ethanoic acid and its salt. So adding H plus produces more ethanoic acid. So if I add H plus, it's going to react with the ethanoate, turn into ethanoic acid. If I add OH, it's going to react with the acid and form sodium ethanoate. And the pH doesn't change very much. So this is what's happening. If I add, here's my buffer system. I've got the salt and then the acid. These are conjugate acid base. If I add H plus, it makes a little bit more of the ethanoic acid. If I added some OH, it would make more of the ethanoate. But the pH will not change very much. So here's what happened with the ethanoate ion. H plus is added to it, but it forms back into ethanoic acid. Ethanoic acid in the buffer reacts with hydroxide, forming ethanoate and water. So here's some different important buffer systems. This is the one in our bloodstream because we have CO2 in our blood from our metabolism processes. Sorry, my computer's having troubles here. So let's try an example problem where we have carbonic acid and carbonate buffer, and we're going to get rid of any additional hydrogen ions or hydroxide ions that come into the system. So we remember the buffer is a salt and its associated acid, or base and associated salt. So carbonic acid can react with hydroxide if it gets thrown into the solution and make this hydrogen carbonate ion and water. That hydrogen carbonate can react with H pluses and form carbonic acid. So this is how we can get rid of OH that gets thrown into the solution, or we can get rid of the H plus gets put into the solution. So that's how it mops up those ions that we don't want, and the pH does not change. So see if you can do it with ethanoic acid. We kind of talked about it already. So see if you can try that one. And let's do a quiz. So which of the following reactions would most likely yield a basic salt solution? So those are those rules I was telling you that would be good to know. So this is going to make a basic salt solution. Okay, choose correct words. And see what you think. So weak acid and salt would go in those blanks. Which of the following equations represents a reaction when a high pH substance is added to the dihydrogen phosphate ion buffer system there? You might need to pause me and think about that one. And here's the answer. And we're done with this. So this is knowing what buffers are. I think you just need to know conceptually what they are, and then maybe one simple example might show up on a quiz or a test. So try those example problems that we had there, and have a great day. I'll talk to you soon.